When connecting to 480 volts motor control centers, specifically MCC-A and MCC-B, several factors must be considered to ensure compliance with the National Electrical Code, or NEC. According to the NEC, if the distance between MCC-A and MCC-B exceeds 10 feet, the connection is classified as a tap. This classification triggers specific requirements outlined in Article 408.12e of the NEC. Because the connection between the two motor control centers is considered a tap, a circuit breaker must be installed at MCC-B to protect the feeder extending from MCC-A to MCC-B. This circuit breaker performs a vital function, providing overcurrent protection for the feeder and safeguarding against short circuits. The circuit breaker also enables a safe and convenient way to disconnect the feeder from MCC-A when maintenance or repairs are needed at MCC-B. Proper sizing of the circuit breaker at MCC-B is essential. The selection must be based on the ampacity of the feeder supplying MCC-B. To determine the appropriate feeder ampacity, a calculation considering the load requirements of MCC-B is necessary. The NEC provides guidance on calculating feeder ampacity based on the connected loads. In instances where the distance between MCC and MCC-B is greater than 10 feet, installing a circuit breaker at MCC-B for the feeder originating from MCC is mandatory. The size of the circuit breaker must align with the ampacity of the feeder, which is determined by the load requirements of MCC-B. Article 408.12e specifically addresses overcurrent protection for feeder taps in motor control centers. This section of the NEC aims to minimize the risk of overcurrents and short circuits that could damage equipment or create hazardous conditions. Taps are generally defined as conductors connected to a feeder at a point between the overcurrent protection device and the load. Because tap conductors are more susceptible to overcurrents, the NEC imposes restrictions on their length and ampacity. The 10-foot tap rule, as it is commonly called, is one of the most frequently used tap rules. It permits a tap conductor to be up to 10 feet long without requiring overcurrent protection at the tap point, provided certain conditions are met. Firstly, the ampacity of the tap conductor must not be less than the combined calculated loads on the circuit supplied by the tap conductor, and not less than the rating of the overcurrent protection device at the termination of the tap conductor. Secondly, the tap conductor must not extend beyond the equipment it supplies. Thirdly, the tap conductor must be installed in a raceway if it leaves the enclosure. In the case of motor control centers, the tap conductors often run between the main bus and individual motor starters. The NEC recognizes that these tap conductors are often short and well protected within the motor control center enclosure. Therefore, the NEC permits these tap conductors to be sized according to the motor full load current, rather than the feeder ampacity. However, when the distance between MCC-A and MCC-B exceeds 10 feet, the tap rule no longer applies, and a circuit breaker is required at MCC-B. This circuit breaker must be sized to protect the feeder conductors from overcurrent and short circuits. The feeder conductors must be sized according to the load requirements of MCC-B. The NEC provides tables that list the ampacity of conductors based on their size and insulation type. The feeder conductors must have an ampacity equal to or greater than the calculated load current. The circuit breaker at MCC-B must have an ampere rating equal to or less than the ampacity of the feeder conductors. The circuit breaker also must be capable of interrupting the available fault current at MCC-B. The available fault current is the amount of current that would flow in a short circuit. The available fault current depends on the impedance of the power source and the impedance of the circuit conductors. The NEC requires that electrical equipment be rated to interrupt the available fault current. The circuit breaker at MCC-B must have an interrupting rating equal to or greater than the available fault current. In addition to the circuit breaker, other safety measures may be necessary to protect the feeder conductors and equipment. These measures may include ground fault protection, surge protection, and overvoltage protection. Ground fault protection is designed to detect and interrupt ground faults. A ground fault occurs when a conductor comes into contact with ground. Ground faults can cause equipment damage and electrical shock. Surge protection is designed to protect equipment from voltage surges. Voltage surges can be caused by lightning, switching operations, and other disturbances. Overvoltage protection is designed to protect equipment from overvoltages. Overvoltages can be caused by faults in the power system. Installing a circuit breaker at MCC-B for the feeder from MCC-A to MCC-B is a critical safety measure. This circuit breaker provides overcurrent protection and safeguards against short circuits. The circuit breaker size must be selected based on the ampacity of the feeder, and the feeder ampacity must be calculated based on the load requirements of MCC-B. The NEC provides detailed guidance on selecting and installing circuit breakers and feeders. It is essential to consult the NEC and other applicable standards to ensure that the electrical installation is safe and compliant.